This video is going to be about an AP type problem that has to do with finding relative extrema and points of inflection. And it's going to be pretty conceptual, but oftentimes these are the types of questions that show up and are asked because they're trying to get at, do you understand the concept? So we're going to start off with a graph, and the graph is just going to be of a function that looks like this. We don't know what the function is, but we know it looks like this. And we have some x values listed. Here is 0, this x value is a, this is b, c, d, e, f, g, and then we're actually going to end it on an open interval at h. And now here's the important thing, and you have to look for this whenever you're given a graph. Is it the graph of f, or is it the graph of f prime or f double prime? In this case, this is the graph of f prime of x, and I'm going to ask you a few questions about it. Here are the questions. So maybe take about 5 to 10 minutes, look at the graph, and see if you can answer some of these questions using the graph. Hopefully you've done that already. So if you haven't, pause it, obviously, whatever. So let's go through them and figure out how to actually do these. So find all the critical numbers of f. Well, this is a vocabulary question. Actually, most of them are. Remember that a critical number is where f prime equals 0 or undefined. So what you do is you look at the graph. Well, here's f prime. Where does f prime equal 0? Well, it equals 0 here at a, here at c, at e, and at g. So my critical numbers are x equals a, the ones we just said, a, c, e, and g. For the second question, when I'm categorizing each critical number as a relative minimum, relative maximum, or neither, this is where I'm going to use my chart. So I'm going to write out each of the intervals. I have 0 to a to c, c to e, e to g, and finally g to h, because remember my function goes between 0 and h. Those are my endpoints, and each break between the intervals are the critical numbers. And so now what I do is I look at the function, because remember we have our intervals, and now we don't need to pick test values because we actually see the derivative of f. We see f prime, and so now we just need to know the sign, S-I-G-N, sign of f prime, and whether it's positive or negative in these intervals. So we go back to the graph. Alright, well, between 0 and a, clearly f prime has negative values. Yes, the slope of f prime is positive, but that's not what we're talking about. We're just talking about the y values of f prime. The y values of f prime are negative, so that means that this is negative. Between a and c, we have positive. Between c and e, we have positive. Between e and g, we have negative. And between g and h, we have positive. So that can go like that. The next line was whether or not f was increasing or decreasing based on f prime. And remember, the relationship here is that if f prime is negative, that means f is decreasing. Positive means increasing, like this. So those are that's the trend of, that's the behavior, rather, of f on these intervals. And now we look for our critical, or rather our characterizations. So here, because f prime changes from negative to positive, this is a relative minimum. I'm not going to write the sentence out, but you should know how to. This is nothing because f prime does not change, it stays positive. Here f prime changes from positive to negative, so this is a relative maximum, so I should say this is neither. And here f prime changes from negative to positive, so this is a relative minimum. And so this is a case where you don't know what the function looks like, but you can still tell what the behavior of f is given f prime. That chart is also nice because it helps us answer the next question. On what intervals is f increasing? Vocab time. Remember, if f is increasing, this simply means that f prime is bigger than 0. So, back over here. The intervals on which f prime is bigger than 0 is, we'll do this in green, a to c, C to E, and G to H. Those are my three intervals where f is increasing, and it's increasing because, if you need to write a reason to justify, because f prime is positive. That's how you know that f is increasing. And now we start getting into a little bit more weirder things. On what intervals is f concave up? Okay, so to answer this question, obviously we have to remember what concave up means. If you do remember, concave up means that, so if f is concave up, or happy, that means that f double prime was positive. So I'm going to write positive. And now, let's actually figure out the relationship between, so you go from f to f double prime. If f is concave up, that means f double prime is positive. But if f double prime is positive, that means that, like, f double prime is the derivative of f prime. So that means that f prime is increasing. And so you can kind of see, like, if the slope of f prime is positive, that means that its derivative, i.e. f double prime, is also positive. And conversely, if f is concave down, that means that f prime is decreasing, which means that f double prime is negative. In the first example, we use the fact that if f prime is positive, then f is increasing, and if f prime is negative, then f is decreasing. And so I've basically taken this whole block and shifted it up one unit, and then it remains the same for this. And that's true of all functions who are related by one derivative. Like, you could have, like, the fourth derivative and the fifth derivative, and if this is positive, then this is increasing. If this is negative, then this is decreasing. That's always true, but we're not going to worry about that right now. So, back to the question. We're looking for the intervals where f is concave up, which means that we're looking for where f double prime is positive, which really means we're looking for where f prime is increasing, because that's the information that we have. Okay, I look at my graph, and I notice where f prime is increasing. Well, it seems to be increasing between 0 and b, because the slope of f prime is positive here. That means f is concave up here. F prime is increasing between C and D, so between C and D, f is concave up. And it's also increasing between f and h, and so that's that final interval where f is concave up. Last question is, where are the points of inflection? Okay, again, you have to think about, alright, what's a point of inflection? Point of inflection is where f changes concavity from concave up to concave down, or vice versa. And if we look at our chart here, well, if f is changing from concave up to concave down, or vice versa, that means that f double prime is changing from negative to positive, or vice versa, or alternatively, and the same, it means that f prime, single prime, is changing from increasing to decreasing, or vice versa. So now if I look at my graph, I'm looking for where f prime is changing from increasing to decreasing, or vice versa, and I have a few points, specifically B, C, D, and F. B, C, D, and F. You could almost think about this as you're finding the critical numbers of f prime, if that's how you want to think about it, but you need to make sure that it's in fact truly changing from increasing to decreasing. Just going back to this handy-dandy chart for a second, you use this information mainly when you're focused with concavity of f and finding points of inflection, and you use the other chart, or this relationship here, when you're looking for relative extrema of just the function f.